Alright everybody, this is our video 7 and we are in the polar unit. Today we're going to be working on converting complex numbers between two different forms. We have polar form of complex numbers and rectangular form of complex numbers. So our rectangular form of complex numbers is the very standard form a plus bi, but we're going to be using x plus yi. So it is exactly the same idea. We're just going to go ahead and use x and y because that's going to relate very simply back to converting between the two forms. And it's going to seem very, very much like what we were doing in the first part of the chapter, converting between the polar and rectangular coordinates. But this time we're working with imaginary numbers. So our trigonomic or polar form of complex numbers is if I were to replace the x with, well, I'll give you the form. We'll talk about that in a second. Cosine plus I sine of theta. Okay, and the shorthand for this one is just r cis theta, and the cis is the CIS, and so it's pronounced cis, r cis theta. So we'd have to pronounce the two numbers, r the radius and theta whatever the angle measure is. So here are relationships. This should not be news to you. X is r cosine of theta and y is r sine of theta. So maybe you can imagine where this information is coming from. And your r is the square root of x squared plus y squared, and tangent is the ratio of y over x. So all of that should be review here at the bottom. Let's keep going. Okay, so how do we get the trigonometric form? If I replace x equals r cosine of theta and y is r sine of theta into this form, so I'd have r cosine of theta plus r sine of theta times I. If I were to remove the r from this and factor it out, I'd have cosine of theta plus sine of theta times I. So I'm going to move the I in front like a coefficient. And this right there is the trigonometric or the polar form, either way, the trigonometric or polar form of complex numbers. R cosine theta plus I sine theta. Again, we can also use r cis theta as our shorthand. So let's try some converting practice problems. The first one, I'm giving it to you in polar form and we're going to convert it to rectangular form. So my end goal is to have x plus yi, which again is the same as a plus bi. So I recognize here that my r value is 2 and the theta that I'm working with is 300 degrees. So just as we converted in the first half of this unit, we're going to be having x to equal r times the cosine of theta, or in this case 2 times the cosine of 300 degrees, and y equals r sine of theta, or 2 times the sine of 300 degrees. So please note that where 300 degrees is in the fourth quadrant, so whatever our answer is, we have to make sure that it matches to graph in the fourth quadrant. So the cosine of 300 degrees is a half, so this would be 2 times 1/2. And the sine of 300 degrees is the square root of 3 over 2, negative square root of 3 over 2, because it's in the fourth quadrant. And you can draw your triangle or you can use your ordered pairs, whichever works best for you for this. And so my answer here for x value is 1 and the value for y is negative square root of 3. So all I'm left to do is write it in this form, x plus yi. So 1 plus, or you could have written minus, root 3i. And this is your answer. Let's try it again with the 5 cis 135, or 5 cosine 135 plus I sine 135. My r value is 5 and my theta value is 135 degrees. So x will equal 5 times the cosine of 135 degrees and y will equal 5 times the sine of 135 degrees. So let's go ahead and calculate that. This is in the second quadrant where my cosine is negative, so I have 5 times negative root 2 over 2 and 5 times positive root 2 over 2. So my x value is negative 5 root 2 over 2 and my y value is 5 root 2 over 2. that's simplified enough. I do not want 2.5 root 2. We do not use decimals in front of radicals, so you need to use the improper fraction or it'll be marked incorrect. So to write this using x plus yi, I'm simply going to do negative 5 root 2 over 2 plus 5 root 2 over 2i. And this is the rectangular form of a complex number. Alright, so let's go back the other direction. So here my goal is to get this into our cis form, our cis theta form. So I need to then find my r value, which we know to be the square root of x squared plus y squared, and my theta value, which is going to come from using the tangent to equal y over x. So those are the two formulas I'm going to be using on this one. So r equals the square root of negative root 3 squared plus, well, what's the y value? The y value is a 1, so 1 squared. So this turns out to be the square root of 4, or 2. So I'm halfway done with r cis theta. Now I just have to find my theta value. So one trick might be to just go ahead and graph it and put your x and y values on there and then just simplify, and you can use tan inverse in your calculator. So this is in the second quadrant because it's negative square root of 3 and positive 1. Well, this is actually one of our angles that we're very familiar with. It's a 30-degree angle in the quadrant 2. 30 degrees in quadrant 2. So I know that this is my 150-degree angle. So my final answer for this would be 2 cis 150 degrees. Now you can write that in longhand or in shorthand, but be able to recognize it both ways so that you are able to answer it on a multiple choice test. For example, the district assessment. Alright, example number 4. Once again, r equals the square root. Wait a minute, what's my x value? My x value in this case is 0. It's 0 minus 3i. So that would be 0 squared plus negative 3 squared. Notice I am not squaring an imaginary number. I am not squaring an imaginary number. That is extremely important. I'm using the coefficient. I'm using negative 3. I'm not using I. Nor did I use I up here on example number 3 for the 1. I only used the 1. If you use the imaginary, especially if you type it in your calculator, you will get the wrong answer. So this is going to simplify to 3 squared is 9, square rooted is just a 3. So how do I find theta if I can't draw a triangle because I'm going 0? Well, I want you to just think logically more so than in a geometric form of where is this point located at 0, negative 3i? It's located at 270 degrees. So that's my answer. So for this problem, r is a 3, cis 270 degrees, and we're done. Alright, I want you to try these two on your own. Remember, this one is being turned into x plus yi, and number 6 is being turned into r cis theta, or the long form of r cosine of theta plus I sine of theta. So that's the forms you're turning it into, and we'll take a look at those together. In summary, the only things you have to remember for this is the new x plus yi replaces our a plus bi. And the only reason we're doing that is to stay consistent with our x's and y's. And then we have r cosine of theta plus I sine of theta, shorthand to be r cis theta, as our polar form. And the polar form shouldn't really throw you off because it does have r's and thetas, whereas our rectangular form had x's and y's. If you know those 4 little formulas that we had in the first part of this chapter, this is going to be a good section for you as well. Alright, bring that work to class tomorrow and we'll talk about it.